everybody to CSCI 45. Yeah. So it is fourth semester computer science. Oh, shit, I'm getting a copy of that. Hang on. Oh, wait. Yeah, there we go. E-platforms already. 10 seconds into the new semester. So this is fourth semester computer science. Hopefully you guys are all here in computer science. You're not expecting a poetry class or something. This class is probably one of my favorite classes to teach. It's not the hardest. It is fourth semester computer science, and so you're like, well, man, if discrete math was this hard and 41 was this hard and 40, no, it's not harder. It's not harder than discrete math. Theory in computer science is typically the hardest kinds of stuff that you have to do. And in fact, the first homework assignment you're going to do, which is a little warm-up, it's not even supposed to be new material or anything. I put together a little programming assignment for you guys, just to get the juices flowing, see if you remember how to program and stuff like that. We'll get to that in a little bit, but that's from a conversation I had with some friends over winter break. We were all talking about our hardest computer science classes, and nobody said this class, right? For all of us, it was the theory classes, the discrete maths, the theory of computation, number theory, that kind of stuff. So one of my friends was talking about these things called zeta functions, and she's like, you took a whole class on zeta functions. I'm like, what the hell is a zeta function? She's like, I don't know. I'm like, didn't you take a whole class on it? She's like, I know. I still don't know what they are. I'm like, all right, I got to look this up. So after I got home, I look up zeta functions. I still don't know what they are. I clicked on the links. I didn't understand the links that explained what they were either. So there's like a whole hierarchy of things, like, I don't know anything about it. But I was like looking at some of the formulas for it. I'm like, my students can code that. I don't know what it is. I don't know what it's for. I don't know what you use it for, what it does, any of that stuff. You guys can code it. So that's going to be your first program time.
Oh,
so
I already got it.
We'll get to that in a little bit. So this class, though, it's not a C++ class. Hopefully you guys all know C++. Anyone not know C++? You're going to have a hard time. Maybe not. It's not a C++ class. Who cares? This is an assembly programming class. And assembly programming is what C++ turns into. Okay? So when you compile your program, when you type G++ main.cc or compile main.cc, what it's doing is it's taking that source code, that text file that's for people, right? Source code's for people. That's what I tell my dogs. This food is not for dogs, it's for people. And they never believe me. No, I'll eat the pizza. This is for people. People. Source code's for people, right? It's not for computers. In order for a computer to make sense of a program, you have to compile it, right? Like you can't just run the text, right? And so what actually happens underneath the scenes is you got the, what you normally do is you do this, right? You type like G++ main.cc, or you type make, or you type compile, or whatever. Different ways of doing it. If you're in Visual Studio, you click the button like a peasant. But at the end of the day, you get some sort of executable, right? By default, an executable is called a.out, right? You guys all know that. Right. You guys know why it's called a.out?
Is the A assembly?
A is assembly, that's exactly right. Very good. 1 point to Ravenclaw. All right, so yeah, that stands for the assembler output. Okay. So where's the assembler? I don't see the assembler in there anywhere. You run the compiler and it makes an executable. We're doing an assembly class. Where's the assembler? Well, it's hidden inside of it. Okay, there's actually a lot of steps that take place inside of this one little thing here. The G++ is part of something called the GNU compiler collection. Okay, so there's a whole bunch of things that live under the hood. You type G++, there's a lot of different steps that take place in there. And what happens there is a whole lecture, which we're not going to do right now. It's first statement. But the upshot is that somewhere in this arrow here, it goes from the source code into a .s file. A .s file is an assembly file. and then the assembler makes the A dot out, and then after you're done, it deletes the .s file. You just don't see it. Okay. It's invisible. And so why the hell do you need to learn assembly programming? This is a different programming language. It translates from the C++ language into assembly, and it goes from assembly into an executable. So why the hell do you need to know assembly? Why not just write everything in C++ or Java, whatever? Anyone know? Okay.
Speed.
Speed. Speed of programming?
Execution.
Execution speed. Yeah. But usually not. A lot of times the compiler is actually better. Like, do you guys remember -03? Anyone remember that?
Oh boy.
Yep.
This one hack the doctors hate. All right. It's one little thing that makes your code run an order of magnitude faster. A lot of times it can beat people making assembly. Back in the day, you'd absolutely be right. Assembly programming, if you carefully crafted assembly code, you could write code that was much, much, much faster than anything this would make. Nowadays, these things are damn smart, dude. I had friends who worked on optimizers, and man, if you actually list, someone's got Discord open. If you actually list all the different, that's probably me actually. If you list all the different optimizations they do in an assembler, it's like mind-blowing. It's mind-blowing stuff. That said, yeah, actually you're right. So there are times, and it's a usually no though. Usually you're wrong, but sometimes you're right. It's a common assignment in this class to mute Discord. Discord mute. It's a common assignment in this class to beat the compiler, right? Like not with your fist, but like speed-wise, right? So here's an assignment. You've got to do matrix multiplication or something. Write an assembly program that's faster than what the compiler does. That's a common CSCI 45 test. And you can do it sometimes. A lot of times with the compiler. You know, so yeah, so why this class? Why assembly? Speed. Sure. Sometimes. Usually we don't bother. But if you look at like League of Legends, have you guys ever played League of Legends? Anyone here ever played League? Nobody? Really?
Once.
You played it? I'm sorry. Okay, so.
Yeah, I'm installed it. It's fine.
Let me start cursing at you for the next half hour so you feel comfortable in here.
Oh, perfect. Yeah. Could you just tell me that I'm really terrible at it?
You're. Why are you even here? That's League of Legends. So, the reason why I bring it up is because Riot Software, the people that make League of Legends, they were getting frame rate drops when there was a lot of particles on the screen. So they started off optimizing, and they rewrote it a few times in C++, turned the optimizer on, obviously, and rewrote it. They got it faster, but then they kind of hit a wall. And then they're like, all right, we're going to rewrite it in assembly. And they rewrote it, and they rewrote it, and they rewrote it, and they got it to be like an order of magnitude faster. So the particle code became much, much faster due to rewriting it in assembly. So it can happen. It's still a thing. Mostly though, we ignore assembly. Right? If you're working for Google and Facebook, it would be extraordinarily rare for somebody to be like, you know what we need today? Assembly. You know, if you're what? Assembly? What? You know, it would be weird. Not the weirdest thing you've ever seen, but kind of weird. Was that better?
Feeling kind of quirky today? Want to do assembly?
Yeah. So, but it is definitely a thing. And in cases where you absolutely need the maximum performance, absolutely. So, understanding. Understanding architecture. I don't mean like this building, right? You guys ever notice in like Hollywood, it's like half the people, their jobs are architects. You notice that? It's like the default job. Like if you need somebody who's like kind of like upper middle class, I'm an architect. They always run around with like rolled up blueprints and stuff like that. We're talking about a different kind of architecture. We're talking about computer architecture. what's happening inside of that box under there somewhere. Okay, you guys see underneath your desks there should be a little Alienware machine underneath there. Don't steal, please.
Alright, so grab this.
I got a big box here.
It's been 10 minutes if someone wants to switch out.
Yeah, McRelly, you want to take over? What's happening inside of this thing? Right? What the hell is happening? When you run a computer program, what's happening? When I was in your shoes, I had no idea. It was magic. You type A dot out, right? It prints a little world on the screen, right? How? Right? How the hell did that happen? How did the word, like I got this thing and I type a thing and then the words appear? To me, it was like this giant like question box, like in Mario Brothers, right? You know what I mean? Like, what the hell is inside of that thing? I don't know. You know, it's magic, right? This class is designed to pull the blanket out of the way and expose what's actually happening inside of a computer. And by doing assembly programming, and by taking the lectures in this class, you're going to actually understand what's happening inside of your computer. And the reason why that matters is not because you're going to necessarily be an assembly programmer in the future, but because if you understand what's happening inside of your computer, you can write better code. Okay? If you were to like, let's say you wanted to add up all the numbers in a 2D matrix, right? 4 and 3 and 7, you know what I mean? Got a big 2D array. You want to add up all the numbers. You get out them all up like you're reading a book, you know, like this way. Or you can add them up one column at a time. You guys know what I'm saying? Like you got to add them all up. You know, you can add them up a row at a time, a column at a time, a diagonal at a time. I don't know why you do that. You could, right? And from where you're at right now, you're like, well, it's going to take the same amount of time, right? You got a matrix that's 1,000 by 1,000. There's 1,000,000 elements in it. It'll take, it's a million additions, right? Doesn't matter. Wrong. You're all wrong. All of you are wrong. It makes an absolute difference. I'm not insulting. Actually, no, I'm not insulting. Because I was in your shoes. I'm like, it's big O, you know, whatever. It's the same, right? No, it's actually not. Because of that question mark. What the hell is happening inside that box? It'll be an order of magnitude faster if you add it up one row at a time than if you add it up a column at a time. Which makes no sense until you understand what's happening inside of that computer. You guys understand? Not why, but you understand why this class is important. So, in CSCI 41, you learned about data structures, right? Best data structure for the job makes a big difference, right? Like if you use a hash table, right? Way faster than using like a vector to do a database or whatever, like the DMV does. So, in this class, we're learning about the silicon. We're learning about how RAM works, how the caches work inside your system, how the CPU works. And the reason for that is because for things like this, if you don't know what's happening inside of that box, you might make the wrong decision. Okay? And when you go to work for a big company like Microsoft, yes, you're probably not going to be working with assembly. You have to know assembly. Probably. Might not get tested on it. You probably should know it. But if you haven't had this class, you're going to write bad code. Okay? And you might clean up some code. Like you might be looking at this code, and it's like, oh man, that's really ugly code. You clean it up. You submit it to the repo. It's rejected. Why? It's too slow. Because at Microsoft, they check, or at least the group my friend was in, they check to see how fast your code is. So when you submit it, if your code is like let's say you clean it up so it's doing the wrong thing here, your code becomes an order of magnitude slower. The automated checking system goes, nope, get out. You guys understand? You're like, but I cleaned it up. Yeah, I don't care how nice your code is. It's an order of magnitude slower now. Get out. You know, and that's the robot telling you this. Are you guys with me on this? So you're like, I don't understand why it's slower. And they're like, well, it's because you did this instead of this. You know? And if you guys all hit Control Delete on your systems, pulls a task manager, right? Performance. Right here, there's this thing called the resource monitor. If you look at the resource monitor, or if you look at the performance tab here, there's a lot of different words on the screen. I don't know if they're gonna come out in the recording, but if you're at home watching this, Aaron or whoever, random YouTube viewers wanting to learn architecture, good on you. I don't know if you can see this, but just hit Control Delete on your machine if you're using a Mac. I don't know, I can't help you. I used to be a Mac guy, not for a long time. All of these things, you're gonna learn what they are in this class, okay? All these things. All these things. All that stuff that, maybe you know already. But right now, at least when I was in your shoes, to me, it's giant question marks, right? What the hell's all that stuff mean? It'll all be revealed. That's the point of this class. You guys understand? Okay. So, in this class, we're going to be learning assembly. We're going to be learning assembly programming. We're going to be learning about architecture. And we're going to be doing projects. Okay? And I know a lot of you guys are probably excited about the projects, right? If you've heard of this class before. So this here is one of the favorite projects that students in this class made in the past. And I don't know why it has an Ethernet cable on it. I think this room was used as a storage area for the IT guys. All right, are you going to be teaching? Nope. All right, I came in here once. It was like a hoarder, or like storage wars. It's like boxes were everywhere, and all the acoustic tiles were off, and just random stuff here. Clean this off a little bit. So this was a laser cut thing. One of the students had one of those laser cut machines. You guys know what I'm talking about, like a light scribe or something like that.
CNC?
No, not anything that expensive, but it's like a laser cutter, and so you put some plywood or whatever on it, and it cuts out the shapes. And so he found this template online, and they cut it out, and they glued it together and made a little thing, right? And they found, this is on a Lazy Susan, like at a Chinese restaurant, So they found one of these at a antique shop, $10, and then they put the monastery or whatever it is on top of it and glued some horses and cows on it. I'm not really sure why. This wasn't there originally. Why? Because I was doing a project. And the project was the one you can see on the banner over there, Power to the Pi. We did an art show in this class. The reason why we did an art show was because there's that art gallery you kind of walk through every time you come in here. Maybe this is your first time on campus. It's fair. It's my first time in 2 years too, almost. There's an art gallery out there, and I was like, it'd be cool if we did an art project, computer science, show people that computer scientists can be creative. And so the art department very graciously gave us some podiums and some art space. And the rules for that project were they have to be interactive. So one group made a pirate boat, and it had some motion sensors on it, and you'd walk up to it, and the little doors on the pirate ship would open, and it would play like cannons firing, and a fan would turn on, the sails would start billowing, stuff like that. Another group had a box that said pain or pleasure. And you have to put your finger into a hole. And if you hit pain, it shocks you. Not like with electric shock, like one of those vibrating, buzzer kinds of things, And it takes your picture. There's a camera. And if you hit pleasure, then it shows the face of the last person who hit pain. And another group made a stuffed animal and had the stuffed animal, they loaded up with fortune, you know, like from Cowsay on the server. They would have it say random things, and if you pet it, it would like do random stuff. And this one here, when you walked up to it, I don't know if you can see on the front, it might be rotated here. Let's take a look at this over here. Right here, they had an ultrasound sensor on that, so when you walked up, it would detect it. And the goat, which is gone now, which represented Satan, the goat would say, "Hey, spin the church, man, spin the church." And you'd walk up and you'd hear the monks of the church eating on the inside, like dinner sounds, you know, like plates and forks and things like that. Hey, spin the church. And if you spun the church like that, you'd hear all the people on the inside go, "Ah!" And you'd hear plates crashing and things like that. You'd spin it, "Ah!" And then there'd be silence. Then if you didn't spin it for a while, you hear the people get up on the inside of the church and start eating again. And if you hit that, lightning would actually shoot out of the tower, which kind of could have caused a fire, I guess, because this was an actual spark generator. And so that was cool. That was a very cool art project. And then later on, we did a project in which they had to build a sentry gun. And so they're like, you know what we're going to do? We're going to repurpose our church and turn it into a sentry gun. So, what they did was they got a motor and they attached it to the Lazy Susan so the thing could independently rotate. And they attached an ultrasound sensor to it. And what the thing would do is it would rotate like this, and the ultrasound sensor tells you how far away the nearest object is to it. It has a range of about 2 meters. Okay. So it was really terrifying. You go, "Vroom, vroom, vroom," and it would sort of like, once it found kind of the nearest thing, it would sort of like go back and forth. All right, that's the center of mass right there. Then, this is filled with ping pong balls. At the very bottom under there, there's a servo motor. And the servo motor would drop, allowing the ping pong balls to come out of the tube. Gravity-fed automatic weapon. Have you guys ever been to a batting cage? They had a spinning disc. It would spin very, very fast at the bottom here. And so when the servo motor would drop the 40 ping pong balls inside of it, they would all fly out in about a quarter of a second. Fully automatic, hitting center of mass. So when we were demoing these things, the number 2 person in all of the community college district came to visit. The vice chancellor of the California Community College. And she heard that they were doing projects in my class. She's like, "I want to see it." And so the vice president of the school comes, the dean comes, students turn the thing on. We're all standing about this far away from it. Thing looks at the vice chancellor, looks at the vice president, looks at the dean, looks at me, starts sweeping back and forth, and all of us are like, kind of like doing this thing.